In this video, we'll walk through how to perform the measurements for estimating cardiac output with transesophageal echocardiography. I'm Dr. Alex Estelle, and this is Sonocare. If this technique is new to you, or you're just a little fuzzy on how to conceptualize and perform cardiac output calculations, make sure to check out my video here on just that. The first measurement we're going to make is the LVOT diameter in the mid-esophageal 3-chamber view. In this view, we need to ensure our alignment cuts through the largest part of the outflow tract. We should see both valve leaflets opening and closing throughout the cardiac cycle, the sinuses of Valsalva, and proximal aorta. We may need to play with our omniplane angle and degree of retroflexion to ensure our alignment. When we're happy with our alignment, we zoom in on the LVOT and freeze the image in systole with the valve leaflets open. We can then measure from inner edge to inner edge, approximately 5 millimeters below the level of the valve. We need to be careful in making this measurement. As this value is squared in our final calculations, any errors we make here will also be squared. The average for most people is approximately 2 centimeters. So if you're getting a value that's far off from this and your patient's not either very large or very small, you'll need to recheck your alignment and take several measurements to ensure accuracy. Next, we're going to measure the velocity time integral, or VTI, using pulse wave Doppler in the LVOT just below the level of the valve. What we're trying to do is measure both diameter and blood flow at essentially the same point in the LVOT, so we are consistent between measurements. With TEE, we can measure a VTI from a transgastric long axis view or a deep transgastric view. To generate a transgastric long axis view, we advance the probe into the stomach and antiflex until we find the short axis view. We then bring the omniplane angle up to 120 to 140 degrees, at which point we should see the LVOT and aortic valve coming into view. We can then place our pulse wave Doppler gate in the LVOT just below the level of the valve. We may need to advance or withdraw the probe a little bit to best align our Doppler signal with the direction of blood flow. It's important to note that we lose signal for each degree we are off from the true direction of blood flow, and it's not recommended that we take Doppler signals when there's a greater than 20-degree margin of error, as we will markedly underestimate the VTI. To generate a deep transgastric view, we take our omniplane angle back to 0 and advance the probe 5 to 10 centimeters into the stomach beyond where we'd see a typical transgastric view. We then maximally antiflex our probe and slowly withdraw. As the probe makes contact with the stomach overlying the apex of the heart, we should see a foreshortened LV as well as LVOT and aortic valve coming into view. We can then place our pulse wave Doppler gates in the LVOT just below the level of the aortic valve. While this view is a bit more challenging to generate than a typical transgastric view, it's better aligned with the direction of blood flow, so is worth trying for. When we are happy with our alignment, we can capture the Doppler signal and should see a series of smooth parabolic waveforms with each heartbeat. We can then freeze the image and, using the calx function, select LVOT VTI and trace the outside edge of the waveform to determine the VTI. With our LVOT diameter and LVOT VTI measured, we can take these numbers and the heart rate and plug them into our equation to estimate cardiac output. As this technique only requires us to make 2 measurements, it can be done quickly and repeatedly, providing critical information about your patient's condition. I hope you found this video helpful. Now get out there and scan.